In the last winter of the Reich, engineers in drafty halls still talked about steel as if steel could bend time. Outside, rail yards were cratered. The sky belonged to enemy fighters, and fuel was counted in cans, not in tank cars. Yet inside design offices and assembly bays, the language stayed stubbornly technical. Torsion bars, final drives, weld seams, gear ratios. If Germany could not win in the air or at sea, perhaps it could win by building a machine so intimidating that the battlefield itself would hesitate. That hope produced what soldiers later called ghost tanks, armored vehicles conceived for a front that was already slipping away. They were not fantasies in the sense of sketches on napkins. They had drawings with tolerances, weight tables, and part numbers. They had procurement orders, subcontractors, and test schedules. Some had serial plates bolted on, but many would never fire a shot in anger. They would be finished, half finished, or nearly finished, and then the war would end around them like a curtain falling mid-scene. To understand why these tanks never fought, you have to start with the pressure that shaped German armor after 1943. On the Eastern Front, Soviet guns grew in caliber and confidence, and the Red Army learned how to absorb losses and keep coming. On the Western Front, Allied aircraft turned daylight movement into a gamble. A column seen from above was a column doomed to burn. German doctrine suddenly demanded thick armor, heavy firepower, and high mobility all at once. While the industrial base was bombed, labor was strained, and raw materials were rationed. In that pressure cooker, wonder weapons offered psychological relief. If you could build something perfect, perhaps you could skip the long, grinding arithmetic of attrition. The trap was weight. Every extra millimeter of armor increased mass, and mass poisoned everything else. Tracks had to grow wider to reduce ground pressure. Suspension components had to be stronger. Engines had to be larger, but engines were already scarce. Gearboxes and final drives had to transmit higher torque, and those parts were exactly where German heavy tanks already broke under strain. And if you built a vehicle too heavy for bridges, too heavy for rail transport, and too thirsty for fuel, you had not built a battlefield solution. You had built a logistics crisis wearing armor. Nowhere was that logic more visible than in the Panzer VIII Maus. On paper, it was the ultimate answer to the fear that German armor was being outgunned. Its frontal armor promised near invulnerability. Its main gun was designed to smash opposing tanks at ranges where return fire would be futile. The Maus was not simply a heavy tank. It was a statement that German industry could still produce a monster even while the Reich was shrinking. But a monster has practical needs. The Maus weighed around 200 tons, and that number poisoned the design before it ever reached a frontline road. Bridges could not be trusted. Roads could not always support it. Rail transport demanded special flat cars and careful routing, and routing meant predictable lines that Allied aircraft loved to cut. Fuel consumption was brutal. Even if a Maus reached a battlefield, its pace would be slow, its turning radius awkward, and its mechanical stress relentless. A tank that breaks down becomes a magnet for artillery and air attack. Recovering a 200-ton vehicle under fire is not a plan, it is a prayer. And yet the engineers kept building. Not because they were naive, but because their profession is to solve problems. And the Maus was a problem that demanded solving. They calculated suspension loads and rechecked them. They argued about track wear and cooling. They pursued power transmission ideas that bordered on the exotic, including electrical components intended to tame torque and reduce mechanical failure. They tested hulls and turrets, measured temperatures, and watched prototypes creep along test tracks. For a moment, the impossible obeyed. Every test run, however, revealed the same contradiction. Engineering success was not the same as military usefulness. A tank is not only armor and gun. It is a logistics plan that happens to be armored. It must be fueled, transported, maintained, recovered, and repaired. It must fit on roads and through villages. It must cross bridges and survive mud. It must be available in enough numbers that the enemy cannot simply avoid it. The mouse could frighten intelligence officers and impress visitors, but it could not threaten a campaign. Meanwhile, the strategic clock kept accelerating. Allied aircraft hunted rail lines, bridges, and factories. Every bomb that hit an assembly hall did more than destroy metal. It destroyed schedules, and schedules were the only currency that could still buy the future. By late 1944, German armored forces needed numbers, not monuments. They needed vehicles that could be built quickly, repaired quickly, fueled easily, and fought immediately. The mouse offered none of that. Even those who admired it understood quietly that it had been born too late. Prototypes existed. They ran. They proved the design was real. But the gap between it can move and it can fight in a war is filled with logistics. The mouse became a ghost not because it was imaginary, but because it could not arrive where it could change outcomes. It consumed time, labor, and attention, while the front demanded simpler, harsher answers. This is the first lesson of the ghost tanks. They are not the story of silly ideas. They are the story of a collapsing system trying to manufacture certainty. When front lines were unstable and the sky was hostile, it was tempting to believe that the perfect machine could restore control. German engineers pushed limits because pushing limits was what they still had. The tragedy is that the limits pushed back, and the war moved faster than the drawings. If the Maus was a monument, the E-Series was supposed to be a system. By 1944, German planners were desperate to simplify armor production by standardizing components across a family of vehicles. Lighter reconnaissance machines, medium tanks, assault guns, tank destroyers, and one heavy giant meant to replace the Tiger lineage. The idea was rational on paper. Standard parts meant fewer unique tools, fewer training burdens, fewer machining setups, and fewer spare part nightmares. It was an attempt to drag German industry back toward efficiency, while bombs and shortages pulled it toward improvisation. At the heavy end of that family stood the E-100, a tank that promised mouse-level intimidation without the mouse's most extreme excesses. It was still enormous, far beyond the comfort zone of bridges, rail lines, and engines. But it was framed as practical compared with the 200-ton experiment. Engineers spoke of suspension modules, more conventional power transmission, and the possibility of fitting different guns depending on role. To men looking at maps and casualty charts, the E-100 sounded like a heavy answer that might still be manufacturable. But the E-100's real battlefield was a factory floor. By 1944, Germany was fighting two wars at once, one against Allied armies and one against Allied air power. Production did not fail because engineers forgot how to draw. It failed because electricity died mid-shift, because roofs collapsed, because machine tools were smashed, because transport lines were cut, and because skilled workers were killed, drafted, or displaced. A tank program needed uninterrupted months. Germany was living in interrupted hours. In the daytime, sirens could empty a workshop in minutes, leaving half-finished welds cooling in the open air. When the all-clear sounded, workers returned to find gauges bent, jigs shifted, and tolerances drifting. The same hull plate that looked perfect on a blueprint could be ruined by a warped fixture or a cracked crane hook. And when production was dispersed into smaller sites to reduce bombing losses, quality control became a quiet nightmare. A heavy tank is not forgiving. A tiny misalignment in a turret ring becomes a jam. A small defect in a gear tooth becomes a catastrophic failure under load. The more complex the vehicle, the more it punishes chaos. The E-100 began to take shape anyway. Steel plates could be cut and welded. A hull could be started. Yet as metal went into the frame, the hidden costs multiplied. A tank that heavy demanded a powerful engine, and engines were already being diverted to aircraft and to vehicles that actually fought. It demanded transmissions and final drives that could handle monstrous torque, yet the same weak points that crippled earlier heavy tanks still haunted the workshops. Engineers could specify stronger gears. The question was whether the nation still had the precision machining capacity, the heat treat consistency, and the test time to guarantee that strength in production. Even if an E-100 had rolled out complete, it would have faced the questions that turned the Maus into a ghost. How would it move to the front without being spotted from above? A slow, heavy vehicle must travel on predictable routes. Predictable routes invite fighter bombers, and fighter bombers invite wrecks that block the road behind them. How would it cross rivers when bridges were destroyed and pontoon units were overworked? How would it be fueled in an army that increasingly operated on fumes and captured stocks? How would it be recovered when it broke down on soft ground or narrow roads? With every answer, the tank demanded more supporting equipment, more trained specialists, and more time. By late war, time had become rarer than steel. This was the cruel irony. Engineers were trying to solve tactical problems with mechanical answers, but the real problem had moved up a level. Germany's war was becoming a war of systems: air superiority, fuel access, rail capacity, industrial resilience, and the ability to replace losses quickly. The most advanced tank in the world cannot fight if it cannot arrive. The most well-armored hull is merely a bunker if it has no fuel. Quartermasters understood this in their bones. Many engineers did too, but their desks were still covered in drawings because drawings were the only place where Germany still controlled the rules. Around the E-100, other designs drifted into the same ghostly territory. The Panther II was imagined as a better Panther, heavier and more robust, using lessons bought with burnt wrecks on Russian roads. There were proposals for improved armor slopes, improved turrets, improved drivetrain components, and longer guns. Each improvement came with mass, and mass came with production penalties. The result was a paradox. The more a design promised to survive, the less likely it was to be built in numbers, and numbers were what the battlefield demanded. At the front, crews kept fighting in what they had. They welded extra track links onto armor. They begged for spare final drives. They rationed engine hours, listened to gearboxes, and learned to travel at night and hide in tree lines by day. They did not ask for experimental giants. They asked for reliability and fuel. Yet in the rear, the dream persisted that one new machine could compensate for strategic collapse, that one breakthrough in steel could stand in for lost airfields and empty refineries. Late war conditions punish prototypes in a way peacetime engineering never does. A new vehicle needs test mileage, trained mechanics, spare parts, and disciplined crews who know its weaknesses. It needs workshops that can measure, align, and remachine components. Germany was losing those institutions. Testing grounds were threatened. Skilled labor was drafted. Transport was disrupted. So the E100 and its relatives lived in a half-world. Real enough to consume resources, not real enough to become weapons in the field. That is why the E100 became a ghost even before it was finished. The idea behind it was logical, even elegant. The reality around it was ruin. Steel could still be welded into shape, but the system that turns a shape into battlefield power, fuel, roads, crews, spare parts, air cover, was collapsing. And once a war becomes a war of systems, a single machine, no matter how impressive, cannot bring the system back. In the end, the drawings outlived the war. By early 1945, the geography of German armor became a geography of hiding. Factories moved underground or into forests. Components traveled by night if they traveled at all. Whole programs were scattered into fragments. A turret in one location, a hull in another. Engines promised but never delivered. This dispersal was meant to keep production alive under bombing, but it created a new vulnerability. A tank is an integration project. If you cannot bring the pieces together, you do not have a tank. You have a set of heavy, expensive excuses. At testing grounds and assembly sites, the mood shifted from ambition to triage. Engineers who had spent years thinking in months now thought in days. They made lists of what could be saved, what could be moved, and what must be destroyed. In a war that was ending badly, secrecy became its own form of discipline. If a prototype could not be evacuated, it would not be left for the enemy as a trophy. Men who loved machines learned how to burn them. The mouse is the clearest example. Prototypes had been run and examined, and then the front drew closer like a tightening noose. The tank's very size made it hard to escape. Moving a 200-ton vehicle is slow even in peacetime. And these were not peaceful roads. To move it required clear routes, fuel, and time, and each of those became rarer by the week. When retreating units began to pull back through the same corridors, the mouse became less a weapon and more an obstacle. Something that cannot be moved on demand becomes a liability in a collapsing defense. So the end came not in combat, but in scuttling. Charges, fuel, fire, methods chosen quickly and executed without ceremony. A machine designed to dominate battlefields was reduced to scrap to prevent it from being studied. The act had a peculiar cruelty. To destroy the tank was to admit that the war no longer belonged to tanks. It belonged to aircraft, to artillery, to collapsing supply lines, and to armies that moved faster than the heavy steel could. Elsewhere, the unfinished E100 hull sat like a confession. It was heavy, incomplete, and already obsolete in the only measure that mattered: time. It could not be rushed because a heavy chassis is not forgiving. It needed machining, alignment, and careful assembly. Those are luxuries when a factory expects raids and evacuations. When Allied forces reached the sites where late war projects were stored, they found not miracle weapons, but half-finished problems. There were frames without engines, turrets without optics, components without standardized fittings, and paperwork that explained what the machine was supposed to become. The people who encountered these machines after the fighting often misread what they were seeing. A massive hull in a shed looks like secret power. A turret on a rail car looks like a conspiracy. But the truth was simpler and more instructive. These were the artifacts of a system that could still design, but could no longer deliver. The enemy had not simply broken German tanks on the battlefield, it had broken the chain that turns a drawing into a battalion. For the engineers, that chain had always been the hidden battlefield. A heavy design requires high-grade steel, precise machining, specialized bearings, skilled welders, test tracks, and trained maintenance units. It also requires administrative stability, contracts, transport schedules, and reliable sub-suppliers. By 1945, those prerequisites were shredded. The programs became islands of expertise surrounded by a sea of collapse. Engineers might solve a transmission issue only to discover that the bearing supplier had vanished. They might correct a weld procedure only to discover the skilled welder had been conscripted. They might plan a test run only to find the fuel diverted to an emergency defense unit. This is why the ghost tanks never fought. Not because Germans lacked courage, not because crews lacked will, but because the war had become a contest of endurance and systems. Heavy projects consume time, and time is the one resource a collapsing state cannot manufacture. When the end came, it did not arrive with the dramatic firing of a supergun. It arrived with orders to evacuate, with cranes that could not lift, with trucks that had no fuel, with bridges that were gone. And then, almost overnight, the narrative flipped. Tanks that had been closely guarded became photographed curiosities. Engineers who had worked in secrecy found their work measured in captions and rumors. The ghost tanks were finally seen by the world, not in battle, but in defeat. Their silence became their most honest feature. Proof that engineering ambition, without the logistics to carry it, is just steel waiting for history to pass by. There is a particular sound to abandonment in war, the quiet clank of tools being packed while distant guns grow louder. In some workshops, men scraped grease from rulers and wrapped micrometers in cloth as if they were family heirlooms. In others, clerks fed folders into stoves and watched smoke carry years of calculations into the night. The secret was no longer how to build the next machine. The secret was how to leave nothing useful behind. For a heavy tank, even the roads become a problem written in tonnage. A bridge is not just a crossing, it is a limit. A vehicle like the Mouse could force a whole column to detour, to stop, to bunch up, and bunching up was death under Allied air power. Engineers discussed improbable options, underwater crossings, special recovery tractors, routes that avoided bridges entirely. But each option demanded equipment, training, and time that no longer existed. When Allied troops reached scattered sites, they found ghost tanks the way a doctor finds a symptom. Real, undeniable, and irrelevant to the outcome. Technical teams photographed holes, measured armor, and copied markings. Yet what fascinated them most was the lesson. Germany could still design brilliant mechanisms, but could no longer sustain the system that turns mechanisms into battlefield power. The war had already been decided elsewhere. By then, even steel could not buy Germany another month of war. After the surrender, it became fashionable to tell the ghost tank story as a punchline. Germany built monsters that never mattered. The punchline is comforting because it suggests failure was obvious. It was not obvious to the people living inside it. To an engineer watching a new Soviet gun rip through earlier armor, the desire for thicker plates was not vanity, it was a response to mortality. To a planner staring at shrinking reserves, the idea of one decisive machine had a brutal, almost mathematical logic. If you cannot match the enemy in numbers, You search for overmatch in individual performance. But the ghost tanks prove a deeper truth about industrial war. A weapon is never only itself. A weapon is the network that feeds it. Mines and mills, rail lines and depots, repair shops and training ranges, fuel convoys and spare part bins, commanders who understand limitations, and crews who trust behavior. When that network is broken, the weapon becomes a prop. It can be photographed, admired, and feared, but it cannot change outcomes. This is why the end felt abrupt to those who spent years inside development cycles. In peacetime, a prototype that runs is a milestone. In wartime, it is only the beginning. A prototype must become a production line. A production line must be protected. A fleet must be maintained. A doctrine must be written. None of that can be rushed without penalties. Germany tried to rush anyway. Late war projects piled complexity onto an industrial base that was already bleeding. And every new gearbox, every new suspension variant, every new machining tolerance was another demand placed on a system that could no longer guarantee consistency. The ghost tanks also expose an uncomfortable moral tension inside engineering. Many of the men who built these machines were brilliant craftsmen and designers. Some believed in the regime. Others simply tried to survive. Yet regardless of motive, their work served a state that turned war into a machine for conquest and mass death. In that sense, the silence of the ghost tanks is not only logistical, it is also ethical. A weapon that never fought did not kill in combat, but it still consumed labor, metals, and time that might have fed civilians, repaired rail lines, or maintained vehicles that already existed. Even silence has a cost when a nation is starving for resources. There is an irony the engineers themselves would have recognized. The better the tank became on paper, the more it demanded from the world around it. Thicker armor demanded stronger engines. Stronger engines demanded better fuel. Better fuel demanded refineries and transport. More weight demanded stronger bridges and more recovery vehicles. In a stable system, those demands can be met. In a collapsing system, each demand becomes a confession. You are building for a world you no longer control. In the ruins of 1945, Allied and Soviet technical teams studied captured projects with clinical curiosity. They measured armor thickness, examined welds, and compared suspension choices. But the most valuable lesson was not a trick of metallurgy. It was confirmation that strategic realities dominate tactical brilliance. Air power, logistics, and production capacity are not glamorous, but they are decisive. The German ghost tanks were evidence that a nation can still have clever engineers while losing the larger contest of fuel, transport, and uninterrupted production. That lesson did not die with the war. It resurfaced in every later argument about modernization. Should you build a few exquisite machines or many adequate ones? How much complexity can a maintenance system tolerate? What happens when supply chains are contested? When spare parts must cross oceans? When fuel is scarce? When factories are vulnerable? And when your enemy can interrupt your schedule at will? The ghost tanks whisper a cold answer. Build what you can field, sustain, and replace, not what you can admire in a shed. And yet it would be wrong to end with mockery alone. The ghost tanks are also a human story about the limits of control. Engineers build because building imposes order on a chaotic world. In 1944 and 1945, Germany was losing order on every front. A heavy tank program offered a place where rules still applied. Measurements, angles, strengths, and tolerances. It promised that if you did the calculations correctly, The result would make sense. War is the opposite. War punishes correct calculations when the environment changes faster than the machine can be finished. Imagine a final day in a workshop. A technician wipes his hands, listens to distant artillery, and looks at a hull that will never carry unit numbers. Around him, men argue about whether to torch documents or hide them. A crane stands idle because electricity is gone. A half-assembled drivetrain sits on blocks because the bearing shipment never arrived. The machine is unfinished, but the lesson is complete. Engineering can stretch limits, but it cannot rewrite the conditions that make machines useful. The German perspective on this is not only ideological or technical, it is personal. Many engineers left notebooks full of small victories, a cooling change that reduced overheating, a weld sequence that stopped cracks, a bearing choice that extended track life. In another world, those victories would have mattered. In 1945, they were drowned by larger forces. A single fighter bomber could destroy in seconds what took weeks to machine. A blown bridge could cancel a deployment. A missing train car could halt an entire program. And the true logistics miracles of the last months were not super tanks at all, but ordinary trucks dragging fuel, food, and wounded men through collapsing roads. In that light, the ghost tanks stand as memorials to effort without payoff, and to the bitter moment when even the best workshop could not compete with the enemy's control of skies and rail. So the war ended, and the ghost tanks did what ghosts do. They remained as shapes without purpose, photographs, museum pieces, intelligence trophies, and stories whispered by veterans. They became symbols of a desperate wager that engineering could overcome strategy. It could not. But the wrecks still teach in their silence what modern war always demands: systems first, miracles last.